take a little bit of time to talk about this test. So let's go to Canvas. So in the week 5 module, there's today's class and Thursday to 11 test 1. So I have brought your attention to this a few times before. Info guide, review sheet, practice test answers, and there's the actual test. So this test, if you click on this test right now, it'll tell you that it's not available until Thursday at 11:30. But I'm just going to open it so that you can see what you will see on that day. So when you open this assignment, this is an assignment like your homework where it's just an assignment and then you'll submit something here. So it's not, the questions are not actually in here. You'll have to download the test for the questions. So the procedure, and this is on the information guide too, but this is just a reminder, sign into Zoom and have your camera showing your workspace for the duration of the test. So that means that while you're in Zoom, your camera has to be on and you will need to be showing the space in which you are doing your work. So let's see if I can, on some laptops, so if I move this down a little bit, this is just a laptop on a stack of books that I'm using right now, and I can show my workspace. So if I was writing my test here, that would be just fine. The issue that you might encounter if you choose to do this method is that I can't really see the screen very well when I'm doing that. So you have a choice to either print the test or just write on a separate sheet of paper. So if you're going to print it out, then doing that method of just tilting a laptop down will be totally fine. If you don't have a printer and you need to be looking at the test on the computer, it might be easier to be signed into Zoom on a phone and have it set up to be showing your workspace. Or if you have like a webcam, you can move it as you need to. So you'll just click on this link to download the test. And I'm not really going to show it now, but it will download as a PDF. So you can either just look at it on the computer screen or you can actually print it out. So that is your choice depending on what works for you and what you have access to. When you are finished with the test, you need to tell me in the chat and I will let you know when you can start scanning. So I just want to know when you are going to start scanning so I know why you have your phone out. So you need to scan your test while you're still on camera and upload your completed test to this assignment just like you do your homework. So this is where things might get a little tricky if you are using a phone on the Zoom app to show your workspace. Then you need to switch your Zoom to be on your computer so that you can still be on camera while you are scanning your work. So you should never stop being on camera during the test. Once you have uploaded your test, you need to tell me so I can check to make sure it's in there and everything is good before you leave. So check in with me before you start scanning and check in with me after you've uploaded and before you leave.
Real quick, about how long is the test?
So if you've looked at the practice test, it is the same length. Roughly an hour is how long was roughly the average time last term. I have intentionally made it so it is not meant to be like a time crunch. I want you to have enough time to do the test. And I even made it a little shorter than I normally would if we were in the classroom because of the time it takes to do the Zoom and the scanning and uploading on all of those things. So it's not terribly long. I also put a couple reminders in here. The only resources allowed are Graphing Calculator and or Desmos. So Desmos is the only thing you should be using a computer for other than to access the assignment. Show all of your work unless otherwise indicated and follow instructions. This is a thing that people miss points on. And it's a silly thing to miss points on. Read the instructions and do what is being asked of you. Are there any other questions about how this will work? The test. I did this. Oh, sorry, go ahead.
I remember you mentioning that we could have multiple Zooms open during the test. May I use my telephone for that Zoom?
Yes, so you can sign in
the workspace.
Yes, yep, you can. You can sign into Zoom on multiple devices into the same Zoom meeting, and that's totally fine. I don't think that you can be like in your official CCC account on more than one device, but that's not necessary for what we're doing. No. Sorry, I just have to think. So I am not going to see anything that's on your computer screen, unless you set it up that way, which is fine. But yeah, so you should just have a camera. As long as your camera is showing your workspace and you're on camera the whole time, you can have your different monitors with whatever you need.
Oh, okay.
So we can only like print out the test once it's 11:30, right?
Yes, that's correct.
So if we have a printer in like a different room, should we just take the Zoom like with us?
If you can.
Okay.
Yes. If you're gone for like 10 seconds to go and like get the paper and come back, then I won't be super concerned about it.
Okay, cool. Thank you.
Yeah. So make sure you look at the info guide. This is just sort of a review of what's on the test and this procedure. Review sheet is just important information from chapter 2. The practice test is the actual, like, this will give you an idea of what to expect on the test and the answers for you to check. And then the last thing in here is the only thing where you'll actually turn something in. And just as a reminder, campuses are open. So if you're concerned about your technology or internet connection or whatever, you can always go to a campus computer lab and take the test there during our time. Okay, so if there are any more questions, now is your chance. Otherwise, we're gonna continue on.
I have a question on the practice test where it is the limit is approaching infinity.
Yes.
I'm still not understanding that.
So I will talk about it briefly, but we don't have time to really review things today. So on the practice test,
With C.
yeah, so we have a rational function. And for part C, we want to know the limit as x is approaching infinity. So to find that limit, we will always be looking at, oh, there it is, sorry. The degrees of the numerator and denominator. So that
Okay.
as x approaches infinity, it is the horizontal asymptote that we're really looking for. Oops. So in this case, we have x minus 4 over x squared minus 16. So here is the degree on top or bottom bigger?
Bottom.
Bottom. So what is the limit in the case that the degree on the bottom is bigger if x is going to infinity?
It's infinity plus or minus.
No.
Zero.
0, yes. So when the degree on the bottom is bigger, the limit is always 0.
Okay.
So we'll
So
have to
the-
have those things memorized.
Yes.
Now, do we need to write all that? Degree on the bottom is bigger?
You should give some indication of how you got 0. So writing just degree on the bottom is bigger is enough.
Okay.
So those aren't.
Real quick, Madeline. I'm sorry.
No, go ahead.
I just had a question. Are we gonna be able to have any time today or on Thursday to go over review with you, or is it just kind of on our own right now? Because I don't see any time set aside for that.
There's not time set aside, and I said that have said that before. So if you have questions, then the time is my office hours. You can always email me, tutoring, all of those things. So yeah, we just don't have time in class to get through everything we have to in the term to take time for review. So the 3 cases for the x going towards infinity are on that review sheet as well, the chapter 2 review sheet. So the 3 cases are if the degree on the bottom is bigger, if they're the same degree, or if the degree on the top is bigger. So you do need to know these things. So so today we are going on to chapter 3, which is not on the test, but your last chapter 2 homework is due tonight. The solutions to that homework will become available at midnight when it's due, so that you can see those. And my plan is to grade this homework tomorrow so that you'll have feedback on it before the test. All right, so if there are any other questions about the test, please feel free to email me anytime. And that's not just for tests, always. But we are going to be going on to chapter 3 today. And I'm not sharing the right thing. So we are going to just briefly talk about section 3.1 because it's really just a review of algebra things, but I want to take a calculus perspective on a couple of things, but mostly today we're going to be focusing on section 3.2 and 3.3. So you won't actually have homework on 3.1 specifically, but it's a little review of exponential functions. So section 3.1 is about the constant E and continuous compound interest. So before we talk about those things, something that will come up a lot in this next couple sections is exponential functions. So this is the general definition of an exponential function. So f of x equals b raised to the x power, where b is not 1 and b has to be greater than 0. So the base of an exponential function can be anything as long as it's positive and it's not 1. Exponential functions can have other stuff on them, stuff added and things, but this is sort of our standard form of the exponential function. So in this class, we won't be doing a lot of solving with exponential functions or any really, trying to think to make sure that's true. But we are going to be looking at derivatives of exponential functions. So we'll be using some calculus on them. But first, these are not formulas that you need to have memorized. You have probably seen each of these formulas before, but if not, that's okay. So compound interest. Compound interest is the interest that is added to the principal amount, which is the starting amount, and any interest that's been accrued before. So if you have a savings account, interest is calculated on the amount that's in that account, and then the interest is added. So the next time interest is calculated, it's being calculated from the starting amount and the interest that was added to it afterward. So compound interest has this formula to start with, which is for n compounds per year. So if we're compounding every month, n would be 12. If we're compounding every day, it would be 365. So A is the amount that is in an account, P is the starting amount, R is the interest rate, and T is time. So this is an exponential function because T is the variable here. That's the thing that's changing, and it is in the exponent. Whereas for continuous compound interest, we're not compounding any specific number of times per year. We are compounding all the time. So instead of compounding every month or every day, it's just continuously compounding and never stopping. So these two formulas are related by calculus that we know.
You said R was rate, right?
Yes, exactly, rate. So continuous compound Continuous is the p equals, oops, not p equals, pe to the r t. So this little e is a constant number, which you have probably seen before, and we're gonna talk more about it in just a moment. But e is roughly 2.71. So if we think about this in calculus terms, thinking about compound interest, if we're compounding n times per year, if we want to get that n times per year formula to be continuous compounding, where we're never stopping compounding, this comes from taking the limit as n goes to infinity. So instead of compounding some fixed number of times every year, we are compounding all the time, which means compounding never stops. So we're compounding in infinitely many times. So if we take the limit as n goes to infinity, our compound interest formula turns into the continuous compound interest formula. This limit is where e comes from. So I think sometimes when we first learn about e, when we're learning about e in natural logs, it just sort of is this random number that we learn as 2.71-ish. But this is actually where e comes from. It comes from the limit as we take n to infinity in the compound interest formula. So if we imagine that if p equals 1, r equals 1, and t equals 1. So if we invest $1 with an interest rate of 1, which is 100%, and leave it in an account for 1 year, then this limit looks like this. For E. You're not going to have to actually use this definition ever. We're going to use E as it is, as itself. But it's important to understand that E is not just some arbitrary number that people decided to turn into a natural log. E comes from this really natural limit that comes from something growing in relation to itself. So E is a very special number. It is roughly 2.71, but we will never use the decimal approximation here. We will always just use E. So this is as far as we're going to go in section 3.1. The moral of this story is that E is not arbitrary. It comes from this limit, and it is a very special number, and we'll see more reasons why it's special in the next section when we look at it in a calculus derivative perspective. Okay, so section 3.2 is about derivatives of exponential and logarithmic functions. So we're going to talk about the derivative of the function e to the x. E to the x is often referred to as the natural exponential. So on that very first page for section 3.1, I showed the definition of a general exponential function where we have a base b. And we're going to be focusing first on exponentials where the base is e, that important number that is roughly 2.71. Before we say what the derivative of e to the x actually is, we are going to do a Desmos based in-class activity again. So if you go to the week 5 module, you should now see in the Tuesday 2-9 class a 2-9 in-class activity. So go there and click on that. And I'll briefly explain what you're going to do. I'll give you a moment to get there. So once you are in there, you will see 2 questions. Each of them has a different link. So the first question, I'm just going to open the link so I can show what you'll see. So if we look on the left side here, one of the things is f of x equals b to the x, which is the general exponential function. And then on the bottom, g of x is the derivative of f of x, d dx of f of x. So we have the function and its derivative. And there's a little slider. And so the instructions on the question tell you to move that slider and answer a question about it. The other one has the natural exponential e to the x and its tangent line. So as we move this a, there's a slider on this one too, it changes the value at which the tangent line is touching the exponential function. So there will be one more question about that as well. So read through those and answer those 2 questions. Your answers will be fairly short, but I want you to read through the questions and slide around those things and then note what you see. And we'll go over them together in a little bit after you work on it on your own.